Hey, I've heard from a lot of people this week who are struggling with the application problems that we're doing. And every person who's contacted me has been using laws of sines and cosines to try to solve these. But honestly, for most of them, it's easier using vectors. In fact, anytime you have a problem that involves motion of some kind, use vectors, don't try to draw triangles, and use the laws of sines and cosines. Let's take a look at an example. A cargo ship can travel at a speed of 25 knots in still water and is being steered on a heading of south 36 degrees east. The ocean current in its location is moving due north at a speed of 4 knots. Identify the speed and direction of the ship with respect to land. Let's set this up using vectors, but it still can be useful to sketch this just to see what's going on. So the ship is moving with a heading of south 36 degrees east. That 36 degrees is between the motion and the north-south axis. But in math, we always work with our angles in reference to the x-axis. So we need to subtract this from 90. And we have a 54-degree angle between the x-axis and the ship's motion. The current is moving north, due north, at a speed of 4 knots. So let's draw a vector for the ship. Remember that the x-coordinate, the x component of your motion, is always r cosine theta I hat, and the y component is going to be r sine theta j hat. And check your quadrant. In this quadrant here, moving southeast, x is positive, but y is negative. So we make our y component negative. And then the current is moving due north, so that's simply 4j hat. And then the overall motion, we simply add these two vectors together. So that's 25 cosine 54 degrees I hat minus 25 sine 54 degrees j hat plus 4j hat. Make sure your calculator is in degrees mode when you do this. 25 cosine 54 degrees gives us 14.69 I hat, and negative 25 sine 54 plus 4 gives us negative 16.23 j hat. We can see from this that the x component is positive and the y component is negative. So we are still in quadrant 4. It was pretty obvious in this problem, but sometimes you can't tell just looking at the description of the motion what quadrant you'll end up in. But doing it with vectors will always get you to the right quadrant. Now that we know the overall motion of the ship taking the current into account, we can identify the speed of the ship. That's just the magnitude of this vector. So that's the square root of 14.69 squared plus 16.23 squared, which is 21.89 knots. You may be wondering where that minus sign on the 16.23 went, but since we're squaring it, will give us a positive answer. Whenever you're finding the magnitude of a vector, you can drop the minus signs because they will cancel out when you square it. A common mistake is to keep the minus signs and then not square them properly, and that will throw off your answer. So you'll actually make fewer mistakes if you just make a point of not including the minus signs whenever you're finding your magnitude of a vector. To find the direction, we use theta equals inverse tangent of y over x, I recommend again dropping your minus signs here, and that will give you your reference angle. And then we can use what we know about being in the fourth quadrant to make sure we have our angle right. Inverse tangent of 16.23 divided by 14.69 is 47.85 degrees. Remember that because of the domain restrictions for our inverse trig functions, half the time the inverse tangent will give you an angle in the wrong quadrant anyway. So just don't worry about the minus signs, get that reference angle, and then figure out what quadrant you need to be in, because you'll have to do that anyway. So we know that we're in quadrant 4. That 47.85 degrees is with respect to the x-axis, but our direction as a heading is always with respect to the y-axis. So we find the complement by subtracting from 90 degrees here, and that's 42.15 degrees with respect to the y-axis. So the direction as a heading, we put the north or the south first, and this time it's south, and then we put the angle, 42.15 degrees, and then we put the west or the east. So our speed was 21.89 knots, and our direction is south 42.15 degrees east.